Good evening and Assalamualaikum. How's everyone? Aziz, Lenaka, Sondos,
Salam,
Zayan.
Doctor.
Yeah, okay.
Apa
Today we
khabar?
will, yeah,
How are you?
fine, okay. Alhamdulillah. Okay, today we will continue with where we left in topic, I think we have something outstanding in topic 3, which is on the association. I'll cover the association. And then we move into topic 4. Topic 4 is more on text analytics and text mining. And then we will try, if possible, we'll go quickly if I can move into the topic 5, which is on modeling of uh, model based. Yeah, how do you do modeling the decision making? How do you do model based decision making? Okay, we'll start with where we left out in topic 3. So just go quickly. Sure. Okay. Quickly. Okay. Okay, now it's 8 o'clock. I think I can just continue. We have covered the last week. We have covered the classification method, and then we also have covered the cluster analysis. Remember, the difference between classes and classification is classification with target. So we call them supervised learning, and then cluster analysis is with no target, so it's unsupervised learning. And then there is another unsupervised learning, which is association. Association is another popular data mining method. So it looks into relationship between variables. Remember, in the beginning of this course, we talk about variables. Variables are things that interest us that is pertinent to or or related to particular entity. Yeah, every entity they will have attributes, and then these attributes are called in the database we call them fields, and then they are actually variables that we are keen to look at, and then there are observations on these variables. But between variables to another variables of the same entity, you can see some affinities or some relationship between one variable to another variable. For example, like whether what do you call it? Some, for example, whether people will look into most common thing people say about smoking and cancer, where there is relationship between smoking and cancer. People who have cancer, do they smoke? And the people who do smoke, do they have cancer? There is look into relationship between entities to another between the entities. Yeah, we have instances of these entities, and then we look into relationship between variables to another variables. It is part of machine learning, but it is unsupervised machine learning because it's not related. There is no target. So one is the most common method, common analysis for this association mining is market basket analysis. Market basket analysis is looking into certain aspect. For example, I can give, say, when imagine the people going to market, everybody carry a basket, and then you look into what components, what are the things they have there in their basket. So what similar things every person, what kind of things that they have in the basket. So people who buy burgers, for example, burger buns, and then they should have also burger patties, for example. Those are market basket analysis, association between a variable to another variable. So how do you do this association mining? There are association rule mining. There are three components that you look at it. One is the input. Input is the thing that you look at. And then output, what is the other aspect that you look at, another item. And then you give an example. We call them, actually we call him antecedent and consequent. So what do they have, and then what is the next thing that they have? So you need to have a support count. So example in this case is point of sale transaction. They have in point of sale transaction. In the point of sales transaction, you can begin with an item, then who bought this item, what is the other item that they bought. So you look into frequent affinities between the item. So like in this case, customer who bought a laptop computer and the virus protection software will also buy a extended service plan of 70% of the time. So you see this pattern from the what do you call it, transaction processing system. Yeah, there are transaction processing system. In this case, is the POS, point of sales. Yeah. So association is useful in business, in medicine. So you can see a relationship between symptoms and illnesses. In business, it can be useful in cross-marketing, cross-selling, store design, and so on. Yeah. So the rule for association is you have an if-then statement. So if person buy certain thing, or if person do certain thing, or if person happen to be certain thing, and then you have that is the antecedent, then they will have a consequence. So antecedent and consequence. So you have a collection of items that corresponds to the if portion, and then the consequent item which corresponds to the then portion. And then you will have a support count. Support count is the statistics that you have. Maybe you will look into the point of sales in the machine, any kind of data capture that you do. Yeah. So there are several algorithms. We will not go through the algorithm. We will not go through, because we don't have that time. Unless in the convention in the physical class we go a little bit more, but the ODL we only have 1.5 hours. So we look into we identify the frequent item sets using a priori, a class, FP grows, and some other algorithm. So this is an example of a priori algorithm. It uses a bottom-up approach. You look into group of subsets and then see the subsets, what are the candidates that have the other subsets. Yeah. This is the a priori algorithm. You can see the raw transaction data from transaction number 1234, 1235, and go on until 1239. And then you can see the SKU item number 1, 2, and 3, and 4, 2, 3, and 4, and so on. And then you have this antecedent, which is the number 1. How many support do you have? 3. Number 2, support 3. And then antecedent and the consequent, let's say 1 and 2. If they have 1 and 2, one is the support, 1 is the antecedent, and then we have the consequent 2, we have 3. 1 and 3, that's 4, for example. So you can see that the largest number is when they have 2, they will also have 4. So this is the largest number. You can see these 1, 2, 3, 4 here, 1, 2, and 4. 2 and 4 here. Okay, I think I use this date there. Okay. 2, in this case, 2 and 4, 2 and 4, 2 and 4, 2 and 4, 2 and 4. So there are 5 of them. And so this is a graphical illustration in the K-means algorithm for a priori algorithm. Okay, there is some measurement that you can do in association rule. We call it confidence and also leaf ratio. Confidence is calculated by the support number, amount of support between antecedent and consequent, and the support of antecedent. And then whereas the leaf ratio is between the confidence and the support of consequent and total number of transactions. Yeah. Okay, association rules. uh, see. Okay, hold on. Yeah. Okay. And association rules is ultimately judged on how actionable it is and explain how the relationship between one set, because people buy certain thing and then what will be the result of the other thing. So it is useful in doing, say, preparing the rack in your store when you want to do a combo product, packaging the product, uh, or promote doing a promotion, for example. And that is some example that you can use for association. Okay, now before we move into text mining, I think I'll skip this. I'll move into the next chapter, which is much more detailed in terms of text mining, uh, and then I'll come back to here, text analysis. Okay, but let's just start with here. So, like the numerical data, text is another information that we would or data that we can be aggregated or integrated to build information, so we can help to solve problems and lead to better decisions. So, when we text mining is the process of extracting this information from text data, and then text data is usually referred to as unstructured data. There are structured data and unstructured data. Usually text data are unstructured data. So in order to process this data, we need to prepare or pre-process the unstructured data to become structured data. So that is text mining. So we will come back here. How do we pre-process the text data? Pre-processing the text data will involve tokenizing. Tokenizing is dividing text into separate items. We have punctuation, symbols that need to be removed. We need to do stemming, converting word into a stem or root word. For example, like say some word determination. For example, determination, the root word is determine. For example, calculation, the root word is calculate. We go back to the root word before we do something. That is called stemming. And then you use you so you eliminate the stop words and so on, so that you can calculate the words as tokens. And then low frequency word may be not so useful, and then you can also consolidate words which are synonyms, so you can reduce the number set of tokens. And then you need to look into slang, humor, and sarcasm, which can cause interpretation problems. And then we'll do parsing. So to break the sentence into a set of tokens, yeah. And then, okay, then we'll come back with this frequency term document metrics later. So I'll move on to the next chapter, topic 4, which is the topic that we'll cover today. This is topic 4, actually. Okay. Topic 4 is about text analytics. Text analytics involve information retrieval, information extraction, data mining, as well as web mining. So what is text analytics? Text analytics basically is about information retrieval and text mining. What is information retrieval? Information retrieval compared to data query. Data query is very precise because it's querying the data. Information retrieval is more fuzzy. Because it's not retrieving data, it is retrieving information. In terms of the level of information, data is the raw facts. They are facts, but they are raw. And then information is at the higher level, which is the integration or aggregate of data. We have information, but it is more meaningful, but it became more fuzzy. And then when it became higher, when you aggregate information plus data plus knowledge of understanding and practices and experience, it become knowledge. Knowledge is more fuzzy, more vague. Yeah, so you can see the higher it goes, it become more vague, more fuzzy, and but less but it is more meaningful. Whereas the lower it goes down to data, it is much more accurate, but it is less meaningful. So text analytics is combining information retrieval, information extraction, data mining, and web mining. It combines uh, text mining and information retrieval. That is text analytics. In order to apply text analytics, there are several areas that we look at, which are the information retrieval, or we commonly call search engine. The layman's word for it is search engine, but it's yeah. So, but we usually call it information. Technical, we call it information retrieval. So it involves document matching, link analysis, as well as the search engine. Search engine is about looking into keyword, looking into the metadata, looking into the semantic level, and meaning of the content uh, in a in a in a digital repository. Okay, and then it also applies natural language processing. Natural language processing is using part of speech. This POS is not point of sales. POS is part of speech tagging. We tag a part of speech, and then we do lemmatization, we do word disambiguation, because words, remember I mentioned to you just now, when it become information, it is more ambiguous, it's more fuzzy. So we need to disambiguate it. For example, like certain words have multiple meanings. We call it semantic, multiple semantic. Like example, table can be a chair, can be a furniture. Table can be a furniture, can also be a, a chart or a diagram, or what we call a table. We learn in our visualization table. And then chair can be a furniture, or it can be an act to chair a meeting. Yeah. So those are different meaning that can relate to a phrase or a word. So that is word disambiguation. And then we also involve web mining, where we look into the content of the web. We can also look into the structure of the web or usage of the web mining. And also it involves data mining, where as we discussed last topic, and today's topic is on classification, clustering, association. So all in all, text mining is about discovery of knowledge in textual data. So the field that involved in these topics include statistics, machine learning, management science, artificial intelligence, computer science, and other disciplines. So when we look at text mining, we go back to text mining we covered just now. Uh, it is text are unstructured data. So this is according to McKinsey 2011-2012. About 85 to 90% of all corporate data is some kind of semi-structured or unstructured data. Yeah. So many doubles ability mass that we have our annual reports, we have our all things that we do, accumulation of data that we do in our repository. So in order to stay competitive, we need to tap this kind of data. And then one way is to do text mining. So text mining is a semi-automated process. So far, it's still semi-automated because we need to understand the meaning of uh, the the word or the particular word. You can read about it in study of semiotics. Study of semiotics is the study of science, science, word science. We call it science, semiotic. Yeah, study of science. Yeah. So language is a science. So there are many types of language. So language is a science. So we can it is semi-automated because it's not easy to understand, because every so the category of semiotic, we can look into at the bottom. We have syntactic, which is the rule of the language. And then we have semantic. which is the meaning of the word. So one word can have multiple meaning, and then you have this uh, uh, what do you call it? Say things with similar meanings. For example, you have chair, chair. We have several chairs. I give an example. Table. We have several meaning of tables. Yeah. Synonym, polysem. So we have that is semantic, and then above semantic, we have another term that we call it pragmatic. Pragmatic is the interpretation of the word. They took into context, time, and location. So at different location, different context, words different meaning, yeah, time and location. Yeah. So pragmatic interpretation. Okay. So comparing data mining, we have covered data mining last week and today on the clustering classification, on clustering, and as well as the association. So and text mining, both are looking into novel and useful pattern, and then both are semi-automated processes. But more of these words or text mining are more into unstructured data, because all these Word documents, PDF, text, XML files are unstructured data. So in order to do text mining, we need to impose structure on the text. So you need to pre-process. We have covered a little bit just now on pre-processing. The technology that we can apply is what we call natural language processing, that we can pre-process the data to do tokenizing, we can do parsing, we can do stemming, and then only we do the word count, and then so we can, before we can start mining the structured data. So once we have structured the data, then only we are able to mine the structured data. So benefit of this text mining, so it is obvious, because when we have text-rich data like the court orders, research article, in terms of annual reports, quarterly reports, discharge summaries of medicine, so you can use say case-based reasoning, molecular interactions. You can look into proteomics, genomics, proteomics, technology, patent files, and many more customer comments, particularly when you do sentiment analysis. So we can mine the text that is available from the data, so we can get better understanding of what people want, so we can improve the business. So it can also be used in communication records like spam filtering, email prioritization, categorization, and automatic response generation. So that is text mining. So text mining application area is in information extraction. We're extracting information from data, from written documents. We can do topic tracking. From the search engine, we can do topic tracking. We can also summarize. We have a repository of data, textual data. We can do summarization. We can do categorization. We can do clustering, concept linking, and also we can do question answering, like we have on something on large language models like Llama, like ChatGPT, and so on. So terminology related to text mining include unstructured or semi-structured data. Unstructured is data without any structure. Semi-structured is data with some portion of the data is structured, the other portion of the data is unstructured. Corpus and corpora are plural and singular of the repository of data, which is normally unstructured data. Terms is refer to the words that you use in uh, the data, for example, like chair, tables, and then the concept related to it, pertaining to which is more but aligned to the semantic of it. Stemming is when you look into the morphology of the words, and then you have derivative words, and then you have root words. So the root words will evolve with to become derived words. And then if you will work backward from the derived words, we have these additives and so on, so it will become the root word. And then stop words is something like the, and so on. So it's is the middle of the word that is stop words. You can also have it as include words. Synonym, which is things which have similar meaning, one word with similar meaning. Polysems is many words with what they call it, uh, the other way around. Yeah, one word with synonym, one word with similar meaning, and polysems is many words have same meaning. Yeah, the other way around. Yeah. And tokenization is you tokenize the sentences. Term dictionary is the dictionary that refer to term. You can look into it at WordNet. You can try to look into WordNet. WordNet, you can get the term dictionary. Term dictionary is the term that you use, or something like a thesaurus, yeah, the term dictionary, and word frequency, the frequency of word that appears in certain documents. Part of speech tagging is you tag a part of speech. Um, you can put into noun, verb, adjective, and so on. And then morphology, the evolution of the words from root word to the derivative words. Term by documents is looking into the occurrence of the word in the document. Yeah. And then singular metric value composition is looking into the latent semantic indexing of the word in the document. So the technology that applies in this is called natural language processing. The old, the old way of looking at words in a repository is just by keyword. Natural language processing look into the understanding of natural human language to understand the semantic of it instead of just syntax, but we look into the semantic. Yes, semantic is the meaning of the words, not just the syntax or the rule of the language. So it's a very important concept in text mining because you do not want to have just large number of recall, but you also want to have a large number, a better precision when you retrieve documents, you retrieve words or information from documents. So natural language processing is a subfield of AI, artificial intelligence. Artificial intelligence is about mimicking how human thinks. Human does inductive, deductive, and abductive reasoning. Yeah, deductive, inductive, and abductive reasoning. So we infer certain things based on the components that we see, then that is called inductive, or from what we have assumed, we can infer that something has happened, or backward, we call it deductive reasoning, or the combination, we call it abductive reasoning. This is how human, mimicking of how human thinks. That is part of artificial intelligence, where computational linguistic is where how people, how human being arrange their syntax to deliver some meaning, or we call it semiotic, some meaning. So that is computational linguistic. Every language have different sort of arrangement of their words, of the sentences that they use. So computational linguistic studies it and then convert it into a computational programming. And then this involve NLP involve the understanding of natural human language so that it can be interpreted by the machine, by the computer. So when we communicate with the computer, whatever language we do, the computers understand uh, uh, they are told, as well as when we have some documents or repository that is written in natural language, and then we want the computer to be able to process and analyze the documents. So in this context, in our today's context of business analytics, we have a repository of documents that we have in social media, we have in annual reports, quarterly reports, and then we want it to be able to analyze unstructured data so that we will be able to use it for our decision making. Yeah, that is in our context today. So understanding is about how does human understand, but natural language is very vague, context driven. This is the level that I mentioned to you, which is pragmatic. Then semiotic, we have three levels, which is the syntactic, which is the rule of language, semantic, which is the meaning, and then the pragmatic is where it applies interpretation on the context, on the time and space, or location, where the word moves from different location and then at different time or different context, the meaning of the word changes. So in order to analyze the content in unstructured data or particularly text or transcribed audio and so on. So we need to be able, the computer need to be able to understand what it means before it will be able to analyze them for our decision-making purposes. Yeah, so that is the part of what we call it knowledge modeling. This is my area. Actually, this is my PhD aspect. So that's my PhD is more not on NLP, and my PhD is more on knowledge modeling. Okay, and then challenges in NLP, we look into part of speech tagging. How do you tag the part of speech into noun, verb, and what does it mean? And text segmentation in order to understand the segmentation of the text. Word sense disambiguation. So where we have words with different meanings, so what is the sense of this word in different contexts? Syntax ambiguity. Syntax is the lowest, which is the rule language. And the syntax is ambiguous because it reflects to different semantic and then, of course, different pragmatic. And then imperfect or irregular inputs. So we have short forms and so different languages, combinations, so imperfect or irregular input. And then so speech acts, wow, or thumbs up, which are speech acts that people do. So the dream of the AI community is to have algorithms so that we can automatically read and obtain knowledge from text so that we can convert them into structured data. And then from the structured data, we can analyze them. We can do clustering, we can do classification, we can do association between variables and the words, and then eventually we'll be able to use them to develop models, and then we will make decision based on the context that we have. So one of the thing that one of available data that we can use is the WordNet. This is developed by Princeton University. You can just type WordNet in you can find some WordNet, and then you can see the sense level dictionary that they have in WordNet. And then another one application that been commonly used in the business industry, in business arena, is the sentiment analysis. Sentiment analysis began in the business aspect, but it has moved into today, also moved into the political, but used by politicians. Okay, what is sentiment analysis? Sentiment analysis is about collecting data that you have from repositories, particularly social medias, and then or even complaints, yeah, or reviews. Yeah, you have portals, for example, where there are reviews, and then you have social media that you put you do postings, and then you put in comments about things or complaints. There is, for example, in Malaysia, we have a public complaint bureau, and then you put up your complaint. And then it will be able to capture the sentiments or based on the dictionary that they use, and then decide what is the whether it is positive, negative, and so on your words. And then based on the positive, what are the positive words, the negative, what are the negative words, so that the industry or the company will be able to decide further action that they should do with regard to their product, with regard to their service, for example. Yes, so like for example, like today when we open up our sentiment analysis and sentiment analytics software, which is available, for example, in Salesforce. Salesforce is the product over the cloud. You can subscribe to Salesforce. Salesforce, I think a number of years ago, they have acquired Radius. Radius is a sentiment analysis software company acquired, and then they have installed Radius in their service, and then all users of subscribers of Salesforce are able to use the sentiment analysis software. And then this sentiment analysis software will accept data from crawlers. The crawler will fetch this data from social media like Twitter, like Reddit, like Facebook, and so on. And then once they have gathered all this data, it will analyze this data based on the sentiment, and then it will update the industry on what people felt about their product and services. So, for example, the company can take immediate action on attending to, say, uh, faulty products and so on, so attending to it, or there are services, it can address it by passing to the relevant department to take action on the part of the services, or in the long-term direction, it can improve their services. So that is sentiment analysis. Okay. Besides this thing, NLP task categories involve question answering, involve automatic summarization, natural language generation and understanding. This is what we do when we do this large language model like ChatGPT. And then we have machine translation. When we converse in a different language, it will be translated into a different language. And then foreign language reading and writing, speech recognition, text proofing, optical character recognition when you write letters. There are there are different types of character that we have in the world. We have these block characters, which is the Latin-like characters, which are block characters. And then we have cursive character, the Malay, Jawi, or Arabic letters are Urdu, and so on. These are cursive letters. And then we have CJK, Chinese, Japanese, and Korean character. It's not a word, it's not a letter, it's a character. So you can use optical character recognition for that. And then text mining application involve in improving, like I mentioned, in Salesforce, they uses sentiment analysis to improve their CRM, customer relationship management. They can be used in deception detection, security for security application, or gene identification in medicine, biology, or other research stream analysis. So this is deception detection, mining for lies. So text-based deception detection will get statements from the transcript for processing, look into cues extracted, text process, text processing the software will identify the cue and then will generate the quantified cue and then do classification and label it truthful or deceptive. Okay, this is example. Okay, and then I want to go. Okay, this is for the gene protein interaction. Yeah, the passing part. This is the ontology or gene protein. And then this is the text mining process. We look into the unstructured data and structured data world of, and then it combines with domain expertise, tools and techniques. We have software and hardware limitation, privacy issues, linguistic limitations, and then they will have context-specific knowledge, which is more pragmatic. Yeah. The three steps for text mining process is to establish the corpus. So the corpus is the repository of unstructured data in form of text. It can be coming from text, HTML, XML, and so on. And then it will once it you collected and organized this domain-specific structured data. Why domain-specific? Domain-specific because the meaning, because of the semantic. Different domain will have different semantic. So it's not easy to, I mean, the computing world have not moved into pragmatic yet. They are still at semantic level. So if we have it at syntax level, we have too many uh, um, synonyms, polysemes of different in different discipline. So when you do domain specific, so we reduce the chances of words have different similar words have different meanings, the different semantic. So we look into the domain specific unstructured data, and then we will create term document. So we introduce structure to the corpus, and then we will structure them into the pattern term document matrix. So the establishing the corpus will collect all the relevant unstructured data, digitize and standardize the collection, place it into a common place, and then we'll create the term document, term by document matrix, and then we'll we'll remove the stop word, look into homonyms, synonyms, and do stemming so that you can reduce, combine some derivative words into back to their stem words or their root words. Yeah, do stemming. And then you calculate the row count, binary frequency, log frequency, and then do inverse document frequency. Term document matrix is a sparse matrix. We can reduce the dimension. So we can have a domain expert to look at it manually, or we can do SVD, yeah, single value decomposition. Yeah. Then we will be able to look into patterns, knowledge, and then once it is structured, so we can extract patterns like we do in numerical data mining. So once we have this TDM, which is a matrix, and then we can do classification, text categorization, applying classification, applying clustering, applying association, or we can also look into trend analysis. Remember, when we do classification, we have a target. So we do text categorization. The category should be already be there. It can be a taxonomy or an ontology that we can use to categorize the terms into these categories. So these terms are already in root words, in their root words, because we have the pre-processing that we have done to reduce it to their root words. Then also, that is classification. Another way, you can also look into clustering. We can do bottom-up or top-down, similar like we did clustering just now. We look into hierarchical, or bottom up, or we can do top down, where we can do k-means clustering. We determine the number of k, and then we break it into the k, and then so we can do natural grouping of this text. We can improve the search recall, improve the search precision. We can scatter and gather, and then we can also look into question and answer query specific clustering. Then association, we can also look like we mentioned earlier that we did on numerical data. We can also do on the textual data. We can do association between one category, one variable of category, variable category, category and another category of words. Yeah, so you can do association, and then trend analysis. You can also do trend analysis. So these are the okay, don't skip this. Okay, now we move into sentiment analysis. Okay, from based on the text mining process, one of the way that we can apply in text mining process is when we do sentiment analysis. Sentiment analysis, what are sentiment? Sentiment is belief, our view or opinion and conviction of certain thing. So where do we put our belief, our view, opinion, and conviction? We put in our reports. We put in our comments about things when you write in social media. We when we complain about certain thing, we put in the complaint form, or we reviewing certain thing, we put in the review column in the e-commerce, for example. So we we provide what we feel, our belief, our view, and opinion, and conviction into some data, some okay transaction, you can see TPS, a transaction processing system. So this either it is social media or whatever it is will be scrolled. There will be a crawler that crawl all these documents and fetch it and then put into a repository, and then um, uh, companies like Salesforce or any other companies that do sentiment analysis will subscribe to this data repository, and then will analyze them to provide answer on what do people feel about a certain topic. So we want to analyze the opinion using these various of the automated tools. So in the business industry, in business, we do it mostly in CRM. So there is a lot of CRM software integrated with this sentiment analysis software. So with sentiment analysis software, we can look into the voice of the customer, voice of the market, voice of the employee. We can look into brand management, financial markets, politics, and government intelligence or espionage, anti-terrorism, and many more. So what do these sentiment analysis do? We once they have the data have been crawled, fetched, and then put up into a repository, and then with this repository it will comprise of textual data that we have pre-processed them into their respective root words, and then uh, taking into account the synonyms, the polysemes, and the uh, semantics of this data. So we have this textual data on top here, textual data. This textual data comprised of statement, we have sentiment, and then we take each segment and we look into whether it is objective or subjective, whether it is an opinion or there is a just there is rationale for it. So we look into objective and subjective polarity. How do we determine it? Because there will be a lexicon. Lexicon is a dictionary, can be wordnet or something that been given by the industry, subject matter expert, or people relevant to that industry. That they will provide this lexicon, and then from this lexicon, you will determine certain words that there are counted in the TDM, the term document metrics just now. We saw talk about term document metrics. So whether it is opinion, just opinion, object, whether or subjective opinion or the objective. So with this, so whether it is whether there is sentiment or not. If there is no sentiment, it will go back up. If there is sentiment, and then you will determine whether it is objective or subjective measure, and then you look into the we will look into the negative or positive sentiment, polarity of the sentiment, whether it's about negative words, negative comment, about the product, about the service, about the company, negative, or it is a positive things that people like about the company. So same goes, we will look into the lexicon here and determine whether there is a negative or positive polarity. Then they identify the target for the sentiment. So, and then we'll tabulate and aggregate the sentiment analysis result, showing the polarity and target of the sentiment. So the sentiment detection will look into whether it is just an opinion, subjective, or a very objective matter, fact or objective. If it is a fact, it is objective. If it is an opinion, it's very subjective. So we determine whether it is very subjective or very objective. And then you look into whether it is not negative or positive. Then we will do target identification. So who is the uh, target for the express sentiment, whether it's a person, a product, and so on. So you need to know who is the target. Is it the product? Is it a person? Is it a service? Is it a company? So, and then you aggregate it, and then you will do measurement, and then you will have something like this, which shows the negative, positive polarity as well as subjective, objective polarity of the sentiments. Okay, that is sentiment analysis. Yeah, sentiment analysis. So we use term document this text mining process just now, term document metrics, term by document metrics, and then so we are able to use the data that we have to look into the sentiment analysis application. With sentiment analysis, we can see the voice of the customer, voice of the market, voice of the employee, do brand management. Currently, is also people who use sentiment analysis for uh, politics, promotion, campaign. You can read about it, the previous campaign by Donald Trump. In you can search on it. You can type Facebook, Cambridge Analytics, and Trump, for example, in this previous election. So there is a case related to it. Then, okay, we still have time. So we'll move into web mining. Any question on text mining? Alice, okay? Alice, Haziq, okay? Nasria, okay.
So
We
far,
move
okay.
into, okay, yeah. So we move into web mining. I think by now you are aware that we have the World Wide Web developed around 1995, and when it rides on top of the internet commenced in 1960 something, or actually it was under ARPANET. ARPA was formed in 1950 something, and then ARPA was spin off to produce NASA, National Space Agency, in 1959, something 1990, in early 1960. And then from that, after spin-off of NASA, ARPA continued to develop ARPANET. ARPANET started in 1960, where they started as to do uh, for communication under the Department of Defense US. Among things started with four, and then they expanded that work until it was taken over by, for it to pass on to the National Science Foundation. It became the NSF Net, National Science Foundation Net, until the 1995 or 1990 something. It was decommissioned. Before 1995, it was decommissioned, and then it became the internet, and then it's open to the public. Okay, from the internet, a team from CERN, CERN, which is a research institute related to nuclear in in France, CERN, which in France, is Nuclear Research Institute. The research was led by Professor Tim Berners-Lee, British, working in CERN. So working with CERN, and then he developed what he called the World Wide Web. World Wide Web is a platform, then uses a browser. The browser's name is World Wide Web. Yeah, before we have the Mosaic, the first browser that left the lab, because World Wide Web was only working in the lab, and then HTML and so on. So he designed the web. Today, we have Web 1.0, Web 2.0, Web 3.0, and Web 4.0. Web 1.0 is where we have a server providing content to audiences, which are the other computers. And then is a presentation web 1.0. And then another presentation web is the Web 2.0, where it involves co-creation, where the audience can also put in content and provide content. It's much more, the user actually provide much more content to the web. So example is the Wikipedia, YouTube, Facebook, and other social media. So those are Web 2.0. And then We have Web 3.0, we remove the human, and then we have machine to machine. So web can communicate with another web. We call it, Tim Berners-Lee term it as the semantic web, where they have deliver meaning so that one machine can understand the conversation of another machine. It's machine to machine. So that is the semantic web. Semantic web is not human, it's but anyway, the search engine today applies semantic entailment so that it improves the precision of the retrieval. So semantic web. And that is Web 3.0. And then adding into it the artificial intelligence, we have the Web 4.0. Web 4.0. So web is the largest repository of data. We comprise of the Web 1.0, Web 2.0, 3.0, and also coming Web 4.0, the largest repository of data. So this data is in various format. It is in HTML, XML, text format. So the challenges in processing the web data, it provides great opportunity because the data is big, but that is also the challenge because the data is too big for effective data mining. So it becomes the what do you call it, the idea to have such big data analytics. So, and then the back web is also too complex, too dynamic. It's not specific to a domain. So with, I think I mentioned to you just now about the semantic of it. So there are too many semantic. So, and then of course there will be many pragmatic level of it. So not specific to a domain, and then it has everything. So, but the opportunities are great, and as well as the challenges for this web mining is also great. So web mining is the process of discovering intrinsic relationship between the web data. It's not just combining looking into the text data level, but also the other aspect, which is the linkage and usage of the data. So web mining involves text mining as well as data mining. So there are three basic categories of web mining. We have web content mining, which is much more related to the text mining, looking into how do you unstructured textual content on the web pages, usually in HTML format or some other format, XML, and so on. So that is web content mining. And then web structure mining using looking into the uniform resource locator, or unified resource locator links which is contained in the web pages, and as well as the web usage, meaning how do people visit and uses the web. So this web mining involves several aspects. It includes search engine, sentiment analysis, semantic web, which I refer to as machine to machine, web analytics, and then it combined with page rank algorithm, which is the ranking algorithm, information retrieval, which is just related to the search engine actually. Graph mining. Graph mining is a relationship between the context to another context, not the graph, not the chart, not the chart. We don't call it graph, we call it chart. Graph is a relationship between one component to another component in the one concept or another concept in the web. And then social analytics, listing analysis, search engine it can be applied in search engine optimization once you are familiar with search engine and the page rank algorithm, and then you can determine how to optimize the search in terms of recall and precision, social network analysis, social media analytics, web blog analysis, marketing attribution, customer analysis, and then customer view, 360 customer view, and voice of the customer, particularly relation to sentiment analysis. Yeah. Okay, this is all about data web mining. So, so first we start with we have covered the web content mining, which is much more related to text mining. Now we look into web structure mining. Web structure mining is more into the hyperlinks. The data collected via the web crawlers. Web crawlers are robots that move from server to another server and then fetch this data, put them into an index, a raw index, and then web pages will include hyperlinks, and then we look into authoritative pages to do the ranking mechanism, the hubs, heats, in hyperlink induced topic search algorithm. And then web usage mining, we look into the extraction of information from data through web page visit and extraction. We look into the data stored in the server access logs, referral logs, agent logs, client-side cookies, and then to look into the user characteristic from which country they are and user profile, who are they, and then metadata, page attributes, content attributes, and other usage data. Also, clickstream data and clickstream analysis. And the web usage mining in order to look into can be applied into determining the lifetime value of clients, doing cross-marketing. You can understand people who visited your site, you can use them to do cross-marketing. Evaluate the visitors to do promotional campaigns, and then you can look into user access patterns and then predict user behavior, yeah, based on the learned rules. So once you have collected this data, you can have some rules, and then so you can predict the user behavior, present some dynamic information to users based on their interests and profiles. So you can do prediction. Search engine, okay, now we move to search engine. We have search engine actually it's the information retrieval system combined with the system, what we call it, crawler system. So example is Google, Bing, and Yahoo. They can recall the older one is Alta Vista, which is much more of keyword, and Yahoo added the usage of metadata, and then Google added with the backlink algorithm, or they call it page rank algorithm. It's more about ranking, and then later on Bing or Power Set, yeah, uses what do you call it, sentiment and entailments to improve the precision of the word. So search engine is a software program that search for document based on keywords. It doesn't really search the web. It search the index, yeah, the index based on the keyword, and then keyword plus the metadata plus the semantic entailment. Semantic entailment is determined from the packs of words, the keywords that build up in the whole repository or whole web pages, and then it build up into the to provide some meaning or some semantic of the context of the page, and then only will do them to do ranking. So we have something that we call web crawler. Web crawler, they have schedule. They will crawl the web. Yeah, so web crawler will crawl the web, and then they have fetch the URL and the contents of the web, put them into a document indexer, and then process this document, so this index to become a cache index or index document database, and then it will continue to crawl. This is what we call the freshness of this crawling activity. So we develop index, and then with this index, there is another repository. We call it they have index repository, and then we have a metadata repository. There is a topic later when we look into the development of this data warehouse. We have not looked into the metadata yet. The metadata, there is metadata here. Okay, at the same time, users will post a query. So there is a query form. Google, actually there is a query form. Yahoo, and so on, there is a query form. Once you have this query form, it will analyze them. It will apply natural language processing to analyze, to process the query and determine which is relevant to the query. So if it is derivative words, it will be stamped to the root word or stamp word. root word, and then pick up from the index, find the matching using the for Google. You will use the PageRank algorithm. A lot of search engine today use PageRank this ranking algorithm and rank the page. So this is the search engine combining the information retrieval system, which is getting they actually we can see only the crawler crawl the web, and then the search engine is actually retrieving, or the permission retrieval system is only retrieving from the index. It's same thing like you see in your book. Your book, how do you find items in the book? You go back to, instead of going from the front, you go to the last pages. Last pages, you get the index. From the index, you get the topic, the item, the words, the term, we call it the term. And then in the term, there is the page number. The term, there is a page number. So there goes similar, when you go to this index, there is the term and the URL. And then once you click, it will move to the URL. So this is how search engine works. So search engine comprise of the development cycle. We comprise of the web crawler and document indexer. And then response cycle, which comprise of the query analyzer applying the natural language processing, and document matcher, which is the ranking, doing the ranking. So when you do search engine optimization, it is about looking into the visibility or ranking of your site in the search engine's natural search result, or organic search result, that is the unpaid search result. So that is a part of the internet marketing strategy. So you need to know how the search engine work based on the content. You determine the semantic of it, the HTML, the keyword, the external links, the metadata, and so on. So indexing, actually, you can uh, subscribe, or every time this search engine will advise how they do their search. So indexing will be based on webmaster submission of the URL, as well as the metadata that they put there, and then proactively and continuously crawling the web. Okay, this is in terms of web usage. In terms of web usage mining, clickstream analysis, the user visits the websites. So you need to know from each website, you will collect the data, merge, clean, structure, so that you can identify the users, the session, the page view, and the visits, so that we are able to extract knowledge in terms of the usage patterns, user profile, page profile, visit profile, customer value. So to understand how to increase the customer value, how to improve the website, yeah, and so on. So web analytics metrics will look into how visitors use my website, website usability, traffic sources, where do they come from, looking into their IP, the profile, you can get them to register, and then what do my visitors look like, conversion statistic, how many of the audiences or visitors that visit your website make some transaction, actually become your customer. Yeah, so website usability will look into page view, time on site, downloads. You have click maps, click paths. So the traffic source will be on the referral website. Where do they come from? The search engine, direct, offline campaign, and online campaign. And then I will also look into the visitor profiles. What are the keywords they use, content grouping, geography, time of day, landing page profile, and then conversion statistic, how many new visitors you have, the returning visitors, how many leads do you have, how many sales conversion do you have, how many exit rate or abandonment, means halfway they abandon the sites. So you can have a web analytics dashboard, something like this. This is using Power BI. Yeah. That is the web analytics. Now we move into social media and social analytics. Social analytics is not about social media, it is about social network. What is social network? Social network is about individuals linking with another individual. So it doesn't have to be those that, it doesn't have to be your friend in the social media. It doesn't have to be your follower or your connection in LinkedIn and so on. So they are might not be somebody that you have online linking. It also include those who are not online, meaning that your spouse uh, or your siblings, your parents, or your friends, or people you acquaintance, or people that you deal with. So these are social structure. So it analyzes the social dynamics. So it is an interdisciplinary field looking into social psychology, sociology, statistics, and graph theory. Graph theory is relationship between component to another component. So social network is the social structure composed of individuals linking to each other. But of course, social media is part of the social network analysis that you can do. So social network helps to study relationship between individuals. How do individuals self-organize? How they become emergent? How this complex is the relationship. So it can help us to look into communication network, community network, maybe criminal network, or innovation networks. So social analytics will look into homophily, how you are linking, you like each other, and then multiplexity, mutually, reciprocity, network closure, propinquity, or segmentation. What are the cliques? What are the social circles you are in? The clustering of coefficient, cohesion. You can have distribution, you have bridges, centrality, density, distance, and structural holes in the social structures. Yeah. And then an enabler of this social network is the social media. Social media is an enabler for social network. You have your friends in your social media, which are not your friend actually. So, but they are your network. They are in your network. Uh, so, social media definitions and concepts is an enabling technology of social interactions among people. So it relies on the Web 2.0, like I mentioned earlier. We have Web 1.0, 2.0 is the uh, not all Web 2.0 is social media, but all social media is Web 2.0. Social media is a subset of Web 2.0. Web 2.0 is about co-creation where the audiences or the visitors or the users put in content into the web. So like YouTube and so on. So we have YouTube, that is social media. Wikipedia is a social media. Waze is a social media. Waze is a Web 2.0. Waze is a Web 2.0. Facebook is a Web 2.0. All social media is Web 2.0. Wikipedia is a Web 2.0. But Waze is not social media. Uh, uh, Wikipedia is not social media. There are many more Web 2.0 which are not social media. But social media is an enabling technology for the Web 2.0. So social media will take forms like internet forum, web blogs, social blogs, microblogging, and so on. So it is used in media research and social process. So comparing the social media versus the industrial media. So you know social media, which is the web-based social media, which is different from the traditional or industrial media, such as newspaper, television, and film. The key characteristic comparing the social media and industrial media is in terms of quality. There is different quality. So we have better quality for social media. It is more wide, and then richness is much better. It's using social media. Frequency, social media, people write every second. Yeah, compared to the television, we wait until certain hours where you have the news. And then accessibility, you can access to it anytime. Social media, usability, immediacy, and updatability. So social media is much more better than in some aspects better than the industrial media. So now we do look into how do people uses the social media. There are people who are inactive. They are spectators. They are collectors, joiners, critics, and creators. Yes, and some of you create new content. Some of you just put in content. Critics. Some people just join a group. Some collect. Some just read. Some are just even don't even read, but just become a member, inactive. Okay, social media analytics is a systematic and scientific way to look into to consume this content created by web-based social media audit for the betterment of the organization competitiveness. We can do descriptive analytics, yeah, look into the centrality and dispersion of this data. We can also do social network analysis, association, for example, association that spec, and also we do clustering, and we can also do advanced analytics. So best practices in social media analytics, think of measurement as a guidance system, not a rating system. Track elusive sentiments, and then improve the accuracy of text analysis. It depends on text analysis because we have semantic issues. Look into the ripple effect, look beyond the brand, identify your most powerful influencers, look closely at the accuracy of your analytical tools, incorporate social media intelligence into your business planning. Okay, that is it in today topic 4. Okay. Any question? Maybe we can just go a little bit an introduction on topic. We have, I think, 15 more minutes to topic 5. At least we just any question before I move on. Any question? Asik, Nurul, Nasria, Alice, okay, Lenaka,
So far, okay, Prof.
okay, are you okay? I'm quite fast today. Okay, I'll just move.
Okay,
Yes, okay. Any question? Okay, let me see. Where's topic? Okay, today and then we move into topic 5. Okay, we have done uh, descriptive analytics, and then we have done predictive analytics. So now we move quickly into model-based decision making. We'll move into prescriptive analytics. Prescriptive analytics is about making decision. How do you make decision? Yeah, with some kind of analytical model. So yeah, we have done okay. We have done descriptive analytics, and we move into descriptive and predictive analytics. We're using um, mining, data mining, and then we have did the modeling. So with this modeling, we are able to do some prediction. And then we have covered text analytics, where text analytics can be used in descriptive analytics and predictive analytics. And now today we move into prescriptive analytics. Prescriptive analytics is about making decision. Yeah. How do you make decision based on this analytical model? So descriptive and predictive analytics have created some kind of foundation so that we can have choice alternative. We have models, we have decision tree, we have clustering, we have association, we have classification, and so we can make some grouping to predict. And then now, how do we make decision? So we apply descriptive analytics, predictive analytics to move towards prescriptive analytics. Remember, descriptive analytics, you cannot straight away do prescriptive analytics. You have to start from descriptive analytics, understand what is the situation. Predictive analytics, using that data, you create some models. So from models, you can expect what will be happening in the future. And then we can do prescriptive analytics. Example, prescriptive analytics, we can do profit maximization and so on. So according to this informs, modeling is the key element to prescriptive analytics. We have we involve mathematical modeling. So major modeling issues is about problem identification. So once you have these models, you need to identify the problem and environmental analysis, and then you need to identify the variables. We have influence diagram and so on, and then you will do forecasting. And then there can be some multiple models. So this decision can include multiple models. It can be static model, it can be dynamic model. So we will look into categories of models later. So we have model management. We have models need to be managed. We have model-based management system, or we have knowledge-based modeling. Or decision support system can be used for quantitative analysis, or expert system can uses qualitative knowledge-based models, KB models. And then the current trend is looking into cloud-based modeling tools, and then there can be transparent models, which are multidimensional or visual model. And then they can also be model of the models, which is the influence diagram to build and solve the model. So categorization of models, you can have for the optimization of problems with very few alternatives, you need to find the best solution from a number of alternatives. So what models you use? You can use decision tree, decision tables, analytic hierarchy process. For optimization via algorithm, we can find the best solution with large number of alternatives. You can do step-by-step improvement. We can do linear programming or other mathematical models, network models. Remember, we learned linear models when we were in school. Yeah, y is equal to mx plus c, or a is equal to a x plus b x, something, b plus c, and so on. So those are linear models. We can also use for issues on optimization using an analytic formula. You can use some inventory models. Simulation, we can have several types of simulation. Yeah, so just find a good enough solution using the alternatives, using experimentation. For heuristic issues, you can use rules. Yeah, there are rules. And then you can do heuristic programming. You can have expert system applying artificial intelligence. Predictive models, you can do forecasting models, or you use Markov analysis. You predict the future for a given scenario. Other models, you can use a what-if analysis using a model. You can do financial models or waiting lines. So what is the model? Okay, I think I'll concentrate on this, and then this is the last slide we will do for today, and then we'll come back here later tomorrow, next week. Okay, this is the basic thing that you need to, very important when you want to do decision making. You have these independent variables. Independent variables. What are the independent variables? Independent variables are variables which is independent. It's not related to coming from or resulting from another variable. What is dependent variable? Dependent variables come from arise from another variable. It is the output or outcome of another variables. We have independent variables and we have dependent variables. This is the context that you use in your, if you do your research project later, we do business BRM, uh, business, uh, what do you call it? Business research project, yeah? Methodology, BRM, business research methodology, you will learn about independent variables and dependent variables. But in this course, we are looking into the result variable, decision variables, and mathematical relationship. And then there is uncontrollable variables, and then there will be intermediate variables. What is the result? What is the indecision variable? Decision variables, example, if you spend more in doing promotion, that is your decision. You decide on spending on doing promotion. Yeah. If you spend more in doing promotion, your result variable, will there be an increase in sales? Your result variable, will there be increase in sales? The mathematical relationship is the relationship between the promotion that if you spend on promotion, and then what will be the increase in sales that you will make. Yeah, but there will be an uncontrollable variable. For example, like location, the media that you use. There are things that you are not in control. For example, like there might be some interest rate, there might be some exchange rate. which are uncontrollable variables. And then there will be some intermediate variables, intermediary variables that will happen before you arrive to your result variables. It may be an intervening variables or moderating variables. Yeah. So in your research methodology class, you will learn about dependent variables and independent variables because those are components of theories. Those are components of theories. You look into the dependent variables and your independent variables. Those are components of theories. But in this course, we are looking into decision making. We are looking into analysis. How do you make decision? What are the relationship between the result variables that you target for? Maybe you target for a profit, and then you want to increase your sales, for example, sales to profit. Does every time you increase sales, you will make a profit, or you increase sales, you will make loss? So there is a mathematical relationship between it, because if your contribution margin is negative, later on next week we'll discuss about contribution margin. If your contribution margin is negative, every time you make sales, you will make more loss. You make higher sales, you will make more loss. Higher you make the sales, higher loss you incur. So because your contribution margin is negative. So your mathematical relationship is very important to understand whether when you increase the decision variables or you decrease the decision variables, what will be your result variable? Your result variable is the target that you do in your business. It's the target. It's your goal. But your action is at the decision variables. And then there are also uncontrollable variables like the exchange rate, the fluctuation of currency, the weather, for example, climate change, also anything, the regulation, the new rules, the new tax that imposed on certain businesses, those are not controlled by the company. So these are called uncontrollable variables. And then there will be intermediate variables that act on the mathematical relationship, because we have the y is equal to a plus b plus c. So you have the formula. You can also read more if you want to learn on econometrics. You can read more on econometrics. You can look into the components, how to develop um, the mathematical relationship of these models. So there are some examples here. We have financial investment. You can use the decision variable will be on investment alternatives. The result variables will be on total profit or risk, rate on investment, earnings per share, liquidity level, and the uncontrollable will be on the inflation rate, prime rate, competition, and so on. So I will go in details on the example next week. Yeah? So, but today, I think we need to understand this first. So today we have covered the topic 3 on the association, topic 4 on the text mining and text analytics, and we have covered a little bit on search engine, and then also a little bit on sentiment analysis. Um, and then you read more further detail on your own. Yeah, because actually this is a self-learning, yeah, ODL. And then we also look into, started with this topic 5, which is on modeling, on prescriptive analytics, and then what are the basic models for prescriptive analytics, and we'll go on detail further next week. Okay, so now it's 9:28. Any question? I have another meeting actually at 9:30. So any question? We have 2 minutes. And Alice, Lenaka, okay, Azik. Okay, I will, once it's done, I will upload the recording. So you listen again to the recording, and then you read on your own, yeah, for the to understand better. Same time, please write your name and matrix number in the slide, in the chat, for purpose of recording purposes for mine. Okay. If there is nothing, we can adjourn for today. Yes, Alice. Okay. Assalamualaikum and good evening.
Thank you, Doctor.
Okay.
Thank you,
Thanks,
Doctor.
Prof. Good night, Prof.